Section 6.3, problems continued. We have problem 4 and 5 to do. So let's get started with problem 4. Write an equivalent expression for sine to the fourth power of x that does not contain powers of trigonometric functions greater than 1. So this is a power reduce problem. We're going to start out with sine to the fourth power of x, and we're going to end up with an expression of many terms that do not involve any trigonometric powers other than 1. Okay, so we need our power reducing formulas. Here they are, and we're dealing with the sine function. Now, notice this is only sine squared. We have sine to the fourth. So let me first transfer this over to the paper here. So we have sine square x is equal to 1 minus cosine 2x all divided by 2. There's your identity. Put that in a box so I don't confuse it with anything else. How can we use that to aid us in this? Okay, first of all, what this means is sine of x to the fourth. But we can think of that in a different way. So let's think of it as sine of x squared, and that whole expression there squared. Because based on rule of exponents, power to power multiplies, and you're back here again. Now we have an expression for this, because again, what does that mean by how we write it? We write this as sine square x, and that then has to be squared. Well, that's where this identity comes into play. So we're going to pull that right now and use it. So replace sine square x by its identity, 1 minus the cosine of 2x, all divided by 2, and that has to be squared. That's our starting point. Now we've got a lot of algebra to do, so we need to square the top and square the bottom. So 1 minus the cosine of 2x, all squared, divide by 2 squared. Now I would suggest pull the 1/4 in front, like that. And then let's multiply out 1 minus the cos of 2x times itself twice to work out the square. This way we're not in a fraction, we're just have a fraction multiplied. It's a slightly easier way to view the algebra. It's less messy this way. So let's get that part done. So this is 1/4 times 1 times 1 minus cosine 2x, and another minus cos 2x makes minus 2 cosine 2x. And then careful here, negative cosine 2x times negative cosine 2x is plus the cosine square of 2x. Notice you square the cosine, not the 2x, right? Because cosine 2x times cosine 2x means cosine of 2x all squared. And that's what we have written right here. So let me just squeeze over here. Cosine of 2x all squared, same as cosine square 2x. Okay, the notation can be a bit troublesome sometimes. Okay, how are we doing? Well, we have no power of trigonometric function here other than 1, but we have a power right there. So we need to get rid of that power. And the Pythagorean won't help because that'll replace the cosine square with the sine square. So let's take a look at our power reduce. Oh, we have an identity right there for cosine square, and that's what we have. So we're going to use this one. 1 plus cos 2x over 2. So let's pull that one off to the side there. So now we're going to use cosine square x is 1 plus cosine of 2x all over 2. So this is our identity here that we're going to have to use, and we need to use that right here. Okay. This can get a little tricky. 1/4 in front. Okay, we'll just copy this down. Don't want to lose it. There's nothing to do with it yet. I can distribute the 1/4, but then I got a fraction involved here, and I already have a fraction involved here, so just to keep the 1/4 out in front. So plus, I'm right here. Now, cosine square angle of angle equals 1 plus cosine double the angle. The angle here happens to already be 2x. When you double the angle, it is now 4x. 1 plus cosine of 4x, all divided by 2. So again, why that happens is, think of all of this as your x. And cosine square x is 1 plus cos double the x over 2. So doubling this becomes 4x. That's where it can get a little tricky. And yes, if you had to apply the double angle again, suppose there was a square here, then it would be doubling, and 4x would then be 8x. Yes. So you can do power reduce on 4th power, 6th power, 8th power, 10th power. It's just a whole lot of algebra. Now, one move before we take care of the 1/4, that's waiting in front. Let it wait a little more. Pull this fraction apart. 1/2, and then 1/2 cosine 4x, like that. Now that you have everything separated in pieces, distribute the 1/4. 1/4 times 1, 2/4, or 1/2, cosine 2x. 1/4 times half, that's 1/8. And 1/4 times a half is another 1/8, but that comes with a cosine 4x attached to it. There we go. Now it's all pulled apart in pieces. Now let's see, we've got like terms there and there. This is 2/8. 2/8 and 1/8 make 3/8. These are not like terms. 2x, 4x. These are not like terms. So you just write them down as individual pieces. Plus 1/8 cosine 4x, and we are done. We have now an expression that does not contain powers of trigonometric functions greater than 1. So we got rid of the exponent in the original sine to the 4th, and we've traded the exponent for multi-angles. That's the trade-off, is multi-angles result instead of originally having powers of trig functions. Okay, we have one more to do. Problem 5 right here. Use the fact that the cosine of 210 degrees is negative √3/2. Use that and a half-angle formula to find the exact value of cosine 105. Okay, cosine 105 degrees. So notice that cosine of 105 is 210/2. It's half of 210. So why is that important? Let's take a look at our formula here. We've got cosine of angle divided by 2. So we have 210 divided by 2. That gives us the 105. And that's represented by here. Now notice the alpha, the A value here, is 210. And 210 divided by 2, that's the 105 that we're trying to find. But what I'm saying is this is A. And A A is this amount, not this amount. That's half of A. Just A itself goes right there, and that's 210. So let's put that in. Use our identity here. So we'll write down here A is 210 degrees. Okay, so just noting that, and our identity here then is plus or minus, we're going to have to figure out which to use, equals square root of 1 plus cosine of A, that's 210, divided by 2. So that's using the identity for the half angle for cosine. Oh, okay, that's why we have this piece of information being given right here. Cosine 10 is negative root 3 over 2. Okay, so let's put that value in. Now, if they didn't give us that value, we got to go find it. And we can do that because we have skill to rotate the angle of 210, second quadrant, reference angle, so on. If it's not a known quantity, be a calculator problem there. Plus or minus square root. 1, let's see, cosine 210 is given to be negative root 3 over 2. So that's a minus root 3 over 2. And all of that is divided by 2. And all of that is under the square root. Okay. So we need to simplify this a little bit. So I'm going to take this fraction here, and I'm going to multiply top and bottom by 2, like that. So I'm multiplying the fraction by 1, nothing's going to change. Plus or minus square root of 2 times 1 is 2, minus 2 times root 3, all over 2 times 2 is 4. Okay. Now notice we can simplify by taking the square root of the bottom there, plus or minus square root of 2 minus 2 square root 3. Yes, I know, we have a square root under the square root, and the square root of 4 is 2. Okay. Now, as far as do we use the plus or minus, recall here that it says the plus minus sign is chosen based on the quadrant in which A over 2 lies. So A over 2, who is A over 2? This is A over 2, right? A over 2, it's in the second quadrant. So we choose cosine function, that's negative in the second quadrant. So our final answer will include the minus sign on there out in front. Minus the square root of 2 minus 2 square root 3, all divided by 2. Okay. We could have done some arithmetic in here by factoring out a 2 and then dividing the 4 by 2 as well. In other words, divide this by 2, divide this by 2, and divide this by 2. But then all of this to be under the square root. I chose to take the square root of the top and the square root of the bottom to get the 2 outside of the square root. So it depends on how you want to view your final result. You cannot divide these now. This is inside the square root. This is outside the square root. So if you want to do any division, it has to be done back here when they're all underneath the square root. Okay, that concludes section 6.3 problems.